And one type of observational design is a correlational research. And so the specific type of observational research we're doing is called correlational research. Okay. Then, once we were able to calculate the frequencies, meaning the number of playground equipment and the number of childhood arguments within a particular period of time at a particular playground that had so much equipment, then what we would want to do is we're going to look at the difference between the playgrounds with less than 5 pieces of equipment and the playgrounds with more than 10 pieces of equipment. And we're going to run an analysis, which you don't have to do in this class, but we're going to run an analysis where we're going to look at whether or not there's differences, meaningful differences between the number of or the frequency of childhood arguments in playgrounds where there's less than 5 pieces of playground equipment and in playgrounds where there's more than 5 pieces of playground equipment. Okay. And I wrote down here the process of data collection and analysis, this whole research process I just talked about, and generating theories are intrinsically linked because theories lead to data collection / analysis, and data collection analysis informs theories. So you saw how we got from observation to theory to research question to data collection and then analysis. But then we do the analysis and we find out what it is that actually happened. Does it continue to support the theory that we used in order to develop our research question? Or does it not actually support that theory? And so they're intrinsically linked because then our research will help to inform that theory more than it had been before we had done our research. Okay, so now I'm going to move on to talking a little bit more about other types of variables. So there's situations which we're not at yet, so I'm not going to explain it in depth. But what I am going to tell you in teaching you about variables is that there's situations where instead of looking at the correlation or even predicting one thing from another. So eventually with correlations, we can take it a step further and do what we call a predictive analysis, where we can look at whether or not, even though it's just an internationally occurring environment, we'll be able to eventually look at whether or not number of playground equipment options at a particular playground predicts the number of childhood arguments with a certain amount of accuracy. And in a case like that, when we get to that, we would have what's called a predictor variable, and our predictor variable would be the number of playground equipment options, and our outcome variable would be that it's predicting, what is it predicting? It's our outcome, which is the number of childhood arguments. And it's not going to be perfect, there's error in those situations. But sometimes we actually want to look at whether or not something is causing something else to happen. Correlational research and predictive analyses do not allow us to say anything about causation. They're just saying there's a correlation between the two variables or that we're predicting one from the other. But in both situations, we're just watching something in that naturally occurring environment. And we need to do that often. Think about it. For example, with a predictor and an outcome, like here you see on the right side of these PowerPoints, if we're looking at smoking and lung cancer, we're not going to create an experiment where we're going to give some people cigarettes to smoke and some people no cigarettes, maybe some people a lot of cigarettes to smoke, and look at the differences over time in whether or not they end up with lung cancer. If we were to do something like that, that would be an experimental design, and we're going to talk about that a teeny little bit right now, but then we're going to talk about it much more in depth as we go through a couple of other modules in here, as well as getting to other courses. So because we're not actually going to set up an experiment and have some people smoke a little bit and a lot and some people not smoke at all, because we're not going to put people in harm's way, instead what we're going to do is we're going to watch what's happening. We're going to ask people when they come to the doctor, how many packs of cigarettes do you smoke? And then we're going to look over time at their age at which they ended up with lung cancer or not. And over time, we'll be able to see from a lot of patient data that that whether or not a certain amount of smoking predicts with a certain degree of accuracy, and we even know how much degree of accuracy that is when we do an analysis, whether or not it predicts age at which someone ends up with lung cancer, whether or not they'll end up with lung cancer in their lifetime, but it's all about prediction. Again, there's no cause and effect. All we're doing is predicting, and doctors tend to put a lot of information into a computer about who you are and what you've reported to come up with how likely you are by a certain age to end up with a particular type of cancer or not, and other things as well. But sometimes we actually do want to set up a situation where we can look at cause and effect. And so let's take, for instance, a situation where we were talking about the playground equipment and number of arguments, and let's say we decide that we're going to put children in a situation where there's no playground equipment at all. We're just putting them in an empty playground. And then we're going to put them in a playground where there's 1 to 2 pieces of equipment. Okay, and then we're going to put them in a playground where there's 5 pieces of equipment. So anywhere from, 5 pieces of equipment. So let's say we'll do no equipment, 2 pieces of equipment, 5 pieces of equipment, and 10 pieces of equipment. Okay, and what we're going to do there is we're going to say that I am going to, of a sample of children who are between the ages of 6 and, let's say, we'll go with like Piaget stages, so they're all in the same kind of stage of life. Let's say they're between the ages of 3 and 5, and we're going to put them in a playground situation, and we're going to see what ends up happening. We're going to watch to see the number of arguments. And so what we're going to do is we want to randomly assign these children from the sample that we have. We want to randomly assign, so let's say our sample is just like 50 children. We want to randomly assign, well, we want an equal number in each. So let's say we have 60 children. So let's say we're going to put 15 children in a situation where they have no toys, 15 children in a situation where they have, instead of doing exact numbers, let's say 1 to 2 toys to play with. Let's put more children in a situation where they have 3 to 5 pieces of playground equipment to play with, and the last 15 children in a group where they're going to have anywhere from 6 to 10 pieces of equipment to play with. And then we're going to look at the frequencies over time. Now, we have defined our variables in that situation as we're still looking at whether or not the number of playground equipment is doing something to the number of arguments. But what's happening here is that we're measuring the one variable, which is going to be our number of playground equipment is still the same thing, the number of playground equipment, but each group is going to have a different number, playground equipment. So it's actually, again, we're measuring that as the number of pieces of playground equipment at the playground that they've been assigned to. And the other variable, which is the number of arguments, we're going to define not just as the number of arguments, but we're going to take it a step further, which we would have done previously as well, and what we're about to talk about. And we're going to say that we're going to actually operationally define what argument means. Whenever we use words like argument, unlike a number of pieces of playground equipment, it's not already operationalized for us. Operationalized means an exact, actual measurement of what it is that you are calling your label conceptually, which in this case is arguments. What happens if you have 3 different experimenters on 3 different days go and collect the data? What if I define argument differently than you defined it, argument differently than somebody else defines argument? What if I think of an argument as people have to be in a fist fight? What if you define it as somebody where they're just arguing? What if another person defines it where a person actually has to be really visibly emotionally upset, like crying or something? And so we need to define what is argument. So let's say we just define it as raising their voices above a certain level. Let's say raising their voice is enough that if you're sitting on the bench away from the toys, you can actually hear clearly what the children are talking about. And it's clear that they're not happy with each other. We know they're not happy because they're looking at each other with a frown. And they're talking in a voice that's loud enough that we can hear across the playground. And they're not smiling, and it's clear they're not happy. Still, it's a little vague, but it's much more operationalized. So then what we're saying there is now we've operationalized those variables, and now we can actually collect the data more specifically without there being any errors between researchers in what they're collecting. And because we randomly assign people, and the rule of random assignment is such that if we take a group of similar individuals, children between the ages of 3 and 5 who are typical children, and we end up putting them in these 4 different situations. Let's say that these are all kids who also go to a daycare situation or a preschool situation, let's say. And we put them into these 4 different playground situations. The rule of random assignment is, since we randomly did this, meaning it wasn't just every other person that came to the experiment, and it wasn't just the first half or the first 15 and then the second 15 and the second 15 and the third 15 and then the fourth 15. Instead, we're actually going to randomly assign, doing things like flipping a coin or coming up with a list of randomly assigned numbers in a spreadsheet, bringing them with us. You can calculate stuff like that in Excel, for example. Bring them with you. And then you end up not having to deal with the fact that there might be other reasons so the rule of random assignment is if you randomly assign them based on what I just said, that means that by randomly assigning them, that they should have an equal amount of the same variability from one group to another, meaning that there shouldn't be meaningful differences in the ways that the children have already previously learned to interact with each other, because they're already similar when we brought them in, and now we randomly assign them. So any differences already that there were between them and their ability to share prior to coming to the playground, or the education they received around sharing prior to the coming to the playground, should now be equal across the groups. And so because of that, if we run this study, the only thing that should be different, if we actually see differences in the number of arguments happening, the only thing that should be different across the different groups that would have prompted those arguments would have been the number of playground equipment, because that should have been the only thing that would have been different.